Hey everyone, here is a quick video showing you the incredible, awesome power of implicit differentiation. So one of the very first things that we can do with this implicit differentiation is take on the inverse trig functions. To appreciate this, take a look at y equals sine to the minus 1 of x. The arc sine, also called the arc sine of x, both mean the inverse operation for x. So if we want to find what is y prime, we don't know what it is, we can rewrite this as an implicit form, in which case we just take the sine of both sides. So we get the sine of y then is equal to x. So by writing it in this form, we can then use our implicit differentiation techniques and we can untangle it. So what do? We take the derivative of this, which the derivative of the sine is the cosine. Don't mess with the inside. Then the derivative of the inside is just that y prime. That's the implicit technique. The derivative of x, that is our variable of note, so that's just going to be 1. Well, we then can say that y prime is equal to 1 over cosine of y. Well, that might be fine, but we would love to know what is that in terms of x. That's the goal. And we just need to rely on our good old Pythagorean identity to be like, okay, well, I know that the sine squared of any variable, we'll call it y now, plus the cosine squared is going to be equal to 1. So I can solve for cosine of y by just saying cosine squared of y then is equal to 1 minus sine squared of y. And so I can get rid of the squaring by square rooting it, all right? So that then can become 1 over the square root of 1 minus sine squared of y. Well, you might say, well, how does that help us? Because we've got a y there and we got a y there. The thing is, if you go back to this, you'll be like, oh yeah, x is what the sine of y is, so this just becomes then the derivative of that inverse sine is just 1 over the square root of 1 minus x squared, okay? So that's what you got to know. The derivative of the inverse cosine is this exact same thing with a minus, all right? So you can derive it the same way we did, and you'll see that that's the difference. So if f of x equals the inverse cosine of x, then f prime of x is just negative 1 over the square root of 1 minus x squared. Okay, what is the inverse of the tangent of x? What is the derivative of the inverse of tangent? I can't talk and write at the same time. What is g prime given that? Well, this is 1 over 1 plus x squared. So look out for that, and apply that. Okay? Good luck, everybody.